Hello everyone. Today I will start talking about ordinary differential equations. And this first lesson will be talking just the basics and how can we classify differential equations. So first of all, uh, we can classify about being an ordinary differential equation. And I will say I will talk about this later. First, let's say we have a function x equals x of t, and I'm using this notation because we usually make physics problems and dynamical systems problems, and t, the variable t, refers to time. Let me write this. And let's say this function is defined in an interval I equals a b. That's a real interval. Um, so first, if we just have uh, x and t, which are two variables, and a independent one, we are talking about ordinary. So when we talk about ordinary differential equations, being ordinary is just that we have x and we have dx dt, which sometimes I will just write being x dot or x prime, and uh, other orders of differentiation like dnx dtn, which is the same of xn, is the nth order of differentiation. So we don't have uh, partial derivatives like dx dt, and let's say we have x is a function of time and is also a function of another variable p, so dx dp. We don't have this. We'll just care about this part, because if we include partial derivatives, so it's not ordinary. This is going to be partial differential equations, which is not the interest of our videos. So another thing we can do is classify about linearity. We can say that a differential equation is linear or nonlinear. And a linear differential equation is one that only contains functions of t and x, the first derivative of x, second, and so on. So a simple approach is to say that linear equations are the form an of t times x nth derivative of t plus, and we go all the way to a2 of t times second derivative plus a1 of t times first derivative plus, and this one only multiplies the function x, equals f of t. Uh, when we are talking about linear differential equations, there's a difference actually. If we say f of t is actually the null function, then we say the linear equation is homogeneous. And if it's different of zero, it is a non-homogeneous equation. Uh, let's take a look on this equation. You see that it's like a linear combination of x and all derivatives of x prime, x prime prime, double prime, all the way through the nth derivative. So it's like a linear combination, but the factors multiplying are functions of t. Uh, and I guess that's it. When we have nonlinear equations, it's because we have something like a cosine of the function x, you know, times, I don't know, t uh, plus uh, t squared times natural logarithm of the first derivative of x equals 0. You know, this is nonlinear because the function x appears inside a cosine and the derivative inside a natural logarithm. So every time we have uh, x prime all the way to nth derivative inside these functions, we say that is nonlinear. What functions I'm talking? I'm talking about cosine, sine, exponential, logarithms, and we can also say absolute value, all these kind of functions. Then we have nonlinear equations. Uh, another thing that that is important to say is about the order of the differential equation. So the order of the differential equation is the greatest let's say degree of derivative. So if I put like x times t plus cosine of t times x prime equals 0. This one is first order because the greatest derivative is the first order. If I put x double prime plus x prime plus x equals some function f of t, this one is second order, and so on. So back to the linear equations, uh, if we satisfy an different of 0, then this is nth order differential equation. And I guess linearity, we have both covered both of cases. We can have homogeneous linear equations, non-homogeneous, and we can have non-linear equations. And yes, I guess we covered all the cases of possible ordinary differential equations. Maybe if I forgot some kind of differential equations, I will say in the next video. But for now, I will just want to say that in the next video, I will cover solving a first order linear homogeneous equation. Uh, then after this video, I can talk about non-homogeneous first order. Then I go to greatest orders, second order maybe. And then I guess all equations we will study will be linear equations. We don't care about nonlinear equations. We'll probably use some methods to linearize those equations and solve for a smaller interval. Uh, that's it. See you next time.